Hello. Today we learn the process of factoring involving the expressions with difference of squares. So difference of squares can only be used when you have a binomial given to you most of the time. So the expression will be given to you as a square minus b square. So you can look that the first and the second term, they both are perfect squares with a negative sign in between. So if this is the scenario, you can factor out this expression as a plus b and this in multiplication with a minus b. So you just need to keep this in mind and you can factor any expression which involves difference of the squares. So we'll take the first example, which is, let us try doing this, x square minus 100. So we have a binomial and we can see that both the terms are perfect square. So x square minus 100 can be written as, this is the square of x and 100 is the square of 10. So this is a square minus b square. We should be able to factor it out as x minus 10 multiplied by x plus 10, and we are done with the factoring. Let us look into another example. X square minus 1. So again for this one, we can see that the first term is a perfect square, the square of x, and the second term 1 is also a perfect square. So it's the square of 1. Now this is a square minus b square. So we can factor it out as x plus 1 multiplied by x minus 1. So you can interchange the position of x plus 1 and x minus 1. That doesn't matter. Even if I would have written it as x minus 1 times x plus 1, it would have still been the same. Let us take another example. 64a square minus 49b square. So again, we can see that the first term and the second term, they both are perfect square. So the square root of 64 is 8a and square. Why this is important is because this is the term and we need the square of the whole term. So 8 square is 64 and a squared can be written as a squared. So in a similar way, 49b squared can be written as the square root of 49 is 7 and b, this is whole squared. So right now, this is our term a and this is our term b. So we should be able to write it down as a minus b multiplied by a plus b, and this has been factored. We will take another example which involves the difference of square with the involvement of common factoring. So the example is 2a square minus 32. If you haven't watched the video for common factoring, please have a look at it. You'll better understand the process. So when an expression is given to us, the very first thing we try to do is the common factoring. Now, between these two terms, we can see that 2 is a common factor. So if we take 2 out as a common factor, we are left with a square. Subtract 32 divided by 2 is 16. Now, this is difference of the squares over here, which we can apply. So this can be written as a square minus 4 square. So we have 2, which is a common factor, and this can be factored out as a plus b times a minus b. So this is the complete process of factoring, which involves the common factoring as well. let us look at a few more examples which will make the process more clear. So we have x cubed y minus y cubed x. Now, what do you think is the common factor over here? So both the terms have an x and a y in common. So if we take xy common, inside the bracket we have x square minus y square. And we can see that again, both of them are perfect squares with a negative sign in between. So the common factor is written as such, and x square minus y square can be factored out as x plus y times x minus y. Now let us look at a few more examples which can involve some other powers apart from the exponent 2. So let us take the question, which is x to the power 4 subtract y to the power 4. Now the question should say factor completely. So here x raised to the power 4 can be written as x squared raised to the power 2. So we can apply the exponent rule. So 2 multiplied by 2 over here gives a 4. And y raised to the power 4 can be written as y squared and the whole square of it, the same thing. So over here our a term is x square and b term is y square. So this can be factored out as x squared minus y squared, that being multiplied by x squared plus y square. This is factored out but not fully, because over here x squared minus y squared can be factored out further. So a term over here is x, b term over here is y. So the first expression, we'll write it out as x plus y multiplied by x minus y. But this term cannot be factored out using difference of the squares, because the two perfect squares are there, but they do not involve a negative sign in between. So this expression or this factor just needs to be written down as x square plus y square. And now this is the completely factored expression for the given question. Let us take another example, which is a raised to the power 6 minus b raised to the power 4. So here a to the power 6 can be written as a perfect square. So we can write it as a cube and the whole square of it. So 3 times 2 gives us a 6, and we'll subtract b square whole square. So right now our a term is a cube and b term is b square. So this can be factored out as the first term minus the second term being multiplied the first term plus the second term, and now this is the completely factored form. Hope you understood and enjoyed the video. See you in the next one. Bye-bye.